Hey everyone, Mr. Schachter here to talk about U substitution. The objective of this video to define indefinite integrals. So the definition of an indefinite integral is the family of all antiderivatives of a function lowercase f of x. And we know that a definite integral is solving for a constant. So an indefinite integral, meaning an integral with no bounds, now is solving for a family of functions. Notice an indefinite integral is very similar in notation to a definite integral, but it is very different from what it actually represents. Here's some rules of indefinite integrals. Know them, study them. Let's try an example. Evaluate the indefinite integral x squared minus sine x dx. Now notice there is no bounds in this integral. So we're going to use our normal anti-differentiation rules. The antiderivative of x to the second, which would be x to the third over 3. And then the antiderivative of negative sine x would be positive cosine x. And then you have to add a plus c. Now this is the new part for us. Whenever you're taking an antiderivative, you have to add a plus c at the end. What about this one? If we tried to use our rules on the square root of 2x plus 1, I could rewrite this problem as the integral of 2x plus 1 to the 1/2 power, right? dx. And I could now try my integration rules, which of course would add 1 to the power. So this would be 2x plus 1 now to the 3/2 power. And I would divide by that same power, 3/2. And I'd add the plus c. And if I just take this division of 3/2 and move it out front to multiplication of 2/3, my answer would be 2x plus 1 to the 3/2 plus c. And this would be my answer, right? Well, the question is, what happens if we actually were to check this? If we were to see, is this truly the antiderivative? So let's check. If I take the derivative of this, 2/3 times 3/2 just makes 1. So this would be 2x plus 1. I would need to reduce the power by 1. So 3/2 minus 1 would be 1/2 power. And then I would have to multiply by the derivative of the inside, which would be 2, because of the chain rule. So as you can see, the check failed, right? This is a failure. This did not yield the original function. So it turns out, anytime you have to take the antiderivative of something that requires the chain rule, you need to use a new technique known as U substitution.